Akoji is a DevOps engineer. He used to be an IT support specialist. He specializes in Kubernetes, and he is presenting to us what is Kubernetes and how it can be used on multiple platforms. So we're glad to have him here. Again, this is going to be an hour-long webinar, and we're excited to learn more about it. This is the DevOps space, which he's very well versed in, and we can't wait to properly get into it. We are hosting this webinar is UrBizEdge Limited. We are a consulting business. We teach people on how to use, we train people on how to use Excel, Power BI, and financial modeling. We have training on specific subjects such as Power Pivot, Power Query, VBA. We also teach people financial modeling, financial planning, and training, all in the goal of completing their AFM, Advanced Financial Modeler exam. We also teach Python, SQL, and in-depth Excel training. So I'm going to pass this over again to Mr. Akoji. Again, looking at it, he's very well versed in the DevOps space. We're glad to have him here. And I'm going to pass it to him now. I'm going to stop sharing my screen, pass it to him now, and yeah, we are going to start this webinar. So
Anthony, we are ready for you. So you can unmute, take us away. Thanks.
Okay. Good day, everyone. Good evening, good morning, good afternoon from any part of the world you are on. My name is Anthony, and thank you, Chidi, for the introduction. So going straight to the presentation I might have today is can we see my screen, please?
Yes.
Okay. So let me just go to presentation mode. Today we're going to be talking about Kubernetes, and we want to actually look at how or what people must have been hearing. What is Kubernetes? What do we use Kubernetes for? How does Kubernetes integrate into systems for technology of software delivery, software continuous integration, continuous deployment, and it's a very good tool that came out from Google. So today we're going to be, let me just go next slide. So today's topic, we're going to be talking of what Kubernetes is, why do we use Kubernetes, the Kubernetes architecture, Kubernetes components, control plane, node components, Kubernetes features, some of the resources that we have on Kubernetes, best practices for deploying and managing applications on Kubernetes. And we're going to be looking at practicals that are going to be you can use, like for your local machine. You want to test how to use Kubernetes on your local machine, on your on-prem servers, on cloud servers, and you can be able to spin up Kubernetes clusters to actually make sure that they are good for your applications to be delivered. So next we're going to be doing is so Kubernetes is actually, if you've heard the name Kubernetes, some people will be hearing K8S, as the case may be. That's a short form. And this is an open source system for automating containerized applications, deployment, scaling, and also it does management too. So we call it a container management tool. As we've all heard before you hear of Kubernetes, there's another container that we're talking about is Docker. Some of us must have heard Docker. So what Docker does is, Docker is just what you use Docker for is it runs your, maybe you have as a software engineer, front end, back end engineer as you might be, you want to deliver your solution or your application in such a way that the next person can be able to run that application on whatever environment. So that environment now we're talking about is, because we all have different types of machines. You might have a Windows machine, I might have a Linux machine, another person might have a Mac operating system. And because we know that there are dependencies that they might be needing for those applications to run, when those or when the engineers actually take those applications and they give it to you, you might need to start installing dependencies before you be able to use those applications. But what Docker does for us is it now compounds all the, maybe your code, everything, all the application, and it turns it into an image. So that image that we're talking about now, when you want to spin up your container or your image from your Docker, it runs as a container on whatever machine that you have. So at that point where you are going to be using that image on your system, you don't need to install any dependency. You're just going to, pull that image from what we call Docker registry. So because of the process that goes on in maintaining different containers, because somebody will say, okay, you have a website, for instance, and you have so many moving parts in that application or in that your website. There's what they call monolithic and microservices. So what Kubernetes does for us in this point is it works with more of like the microservices part of things. So when you're deploying microservices, it means that you have your front end separate, you have your back end separate. Those are the applications that I'm talking about now. Then you have maybe your DB server, for instance, or your database, you have them separate. So now what you do is, in those microservices that you're having, you have to run them as one container at a time. And you might have as many as like 1,000 containers, and you might not be able to, be able to manage those containers as time goes on. So Kubernetes came out as a tool from Google. It was part of a project from Google called Bug, and Google infrastructure started, reaching high scale before like virtual machines, because when you're running those containers from Docker, you'll be running them on virtual machines, you'll be running them on some kind of cloud virtual servers. And because they saw that this will not be sufficient, you might lose track of, like, what container was this running on, and that, and how you can actually connect the two containers, or the two containers you have. Just say you run one as a front end server and you run one as a back end server. How do they connect together? So now Kubernetes now comes in, and it simplifies those things and takes those containers and build them into what they call pods. I'm going to go into that as time goes on, but that's like literally what Kubernetes does for us. So it orchestrates the whole thing, and it makes deployment and scaling and management of those containers better. So why Kubernetes? The reason why you need Kubernetes for your infrastructure or your development or whatever system you have is that it creates a system for you to have high availability. You don't have downtime. Sometimes when software engineers, or there's an upgrade for an application, maybe from the back upgrade. Now, most times, what they do in normal sense is they have to bring down the existing version that they have. And that period, some people might be lagging or not have access to those servers at that point in time. So your network or your application might be down at that point. Then you start seeing people saying, this link is not accessible, this link is not accessible. When is there going to be a resolution, and mean time to resolution to how you can bring that up. So Kubernetes actually takes that away for you, and you know what it makes you you are able to let's say roll out updates for your applications, and you don't have downtime. So it also makes sure that your applications are a load of traffic on your servers. Kubernetes is that smart enough that you can be able to, scale out and scale in as much traffic that you need. So if you're having, for instance, two web servers for your application, and you see that the number of traffic that you're having is too much, it's hitting that peak point, you can actually just use Kubernetes to scale up, and it spins up another server of the replica of that particular application that you have, and it's smart enough to distribute traffic between those servers. So another thing is that what Kubernetes helps us do is, because you have on the Docker side now, when you run containers and the likes like that, you have create volumes or shared folders where you'll be able to save some kind of document or save data or logs that are coming from your application. So Kubernetes now, what it does for you is that it backs up those things, and you can be able to restore back some things that you might be having from your application that went down, and it's a very good disaster recovery tool. So going down to the architecture of Kubernetes, right? So many people, some of us here, we are new to these things, and you might be just what I advise us to do is, at the end of this lecture, Kubernetes is like one of the, I think, tools right now that's in the space that has a very good documentation. So at the end of this lecture, you can go to Kubernetes documentations and have a grasp of whatever that I might be giving out today, and you get more insight about what it really does. So for the architecture now, right? In a Kubernetes cluster, for instance, or what we call the Kubernetes cluster, you hear of what we call master node and worker nodes. So what's the operation behind it is that what it does is, it has a, will I say, like a queen, a king actually, and it has slaves. So now those slaves are what we call worker nodes, and the king is also called either the control plane or you hear master node. So inside this particular master node that we have, there are so many components that are in there that do so many operations, and this is like what you have. So before you can be able to interact with a Kubernetes cluster, there's what they call an API call, which you can run from your command line. When I mean command line, I mean maybe your terminal or whatsoever. So you have an admin at this point. You have an admin here, and that admin is able to use what they call kubectl to actually talk to the Kubernetes cluster. And from that point, what you have for Kubernetes is, when you want to provision your applications and all, because you can't provision them on the master node, what the master node just does is it allocates resources, and it tells, okay, this is where you are supposed to load your application. It gives all these worker nodes that you have the job to do that, and they run your application for you. So I'll come back to explaining most of these concepts that we have here, but let's move forward. So the components of Kubernetes, like I said before, we have sets of worker machines that are called nodes, and that run containerized application. So every cluster has at least a worker node or one worker node, and from here you see, like I said, you have control plane, or you have the master node, and The control plane, it manages these worker nodes and the pods that are in those clusters. Then the worker nodes have they're the ones that host what they call pods that contain the application that you are working with. So we'll go down to the next slide. So I want to break down now what you have inside your control plane or your master node and your worker node. So inside the control plane, we have what we call Cube API, we have etcd, we have Cube Scheduler, we have Cube Control Manager. Then for the worker nodes, we have Kubelets, we have Cube Proxy, and we have Container Runtime. So this is just like a cartoon of API server. Let's just take this as an antenna that receives communication from the will I say the admin that is trying to access a Kubernetes cluster. So now it picks up information. Okay, this is the command that is coming in, and I want it to do this. It sends those commands and it receives it, and it acts on it and shares it for the worker nodes. Now down to the explanation for Cube API server. So Cube API server is a component of Kubernetes control plane that exposes the Kubernetes API. So we have of APIs for maybe software engineering side. Yeah, APIs. What API just does is it tries to link one or two things together for you to be able to access. Let's say, for instance, you don't want your front end server and your back end server to be inside one particular server, and you can have them separately, or you can call them through an API that they can be used to communicate to each other. So Kubernetes too has its own API, and this API server is what exposes the Kubernetes API. So the API is the front end for the Kubernetes control plane. The next one we have on that particular control plane is the etcd, and this etcd, for as we all know, when we build applications, we try as much as possible to create a database. That database is where it stores the logs of all the resources that are coming in. When you have customer A, customer B, you are trying to get information, or you gather information from those people. And what etcd does is it's a consistent and highly available key value store that is used to store Kubernetes cluster data. So all the data that is coming into the Kubernetes cluster, it saves these things, and you'll be able to if you have issues that maybe one particular pod dies or goes off or fails, you can be able to retrieve data from this particular etcd. Next, we have Cube Scheduler. Cube Scheduler is a control plane component or a master node component that watches for created new pods. This explanation, you're going to be seeing it when I'm going to be doing it as a practical. So you might not really understand what I'm trying to do or say right now, but at the end of the day, or at the end of when we get to the practical aspect, you understand more what this Cube Scheduler does. So what it does now is you are creating an application. Now you have that application as a container, and you are going to be loading that application into a pod. So what Cube Scheduler does is when you pull this application from whatever registry you have, either Docker Hub, a private registry, or whatever, the Cube Scheduler is smart enough now to say, okay, this is the command that is coming in. They are supposed to schedule this particular application on worker node 1 or worker node 2 or worker node 3. So, and it tells them, okay, this is where you're supposed to run, and it sends that request through what they call a kubelet. We'll get down to worker nodes later. So the Cube Control Manager is a component that runs, you need to have something that controls the whole process for your system. And this is exactly what this kube controller manager does. So it's logically like a separate process, but it reduces the complexity and it compiles all single binary into just one single process. Next, we have worker nodes. So worker nodes now, they don't have the same components as a master node because they are workers and they are slaves. The components they have is just take whatever you receive from the master and act on it to do your job. So on the worker nodes, we have what we call kubelets, and this kubelet is an agent running on each node. So even the kubelet runs on the master node. The kube proxy tool works on the master node. The container runtime tool works on the master node. Then what the kubelet does now is it is responsible for making containers, or making sure that these containers that they are receiving to act upon are working or are running on the expected nodes they are on. That is, if a pod now has any issue, for instance, that has an application, the kubelet tries to like restart these pods on the same node or on a different node. So next we have kube proxy. When we are trying to do things that have to communicate with each other and the likes, there has to be a networking aspect to these things. And this is where kube proxy comes into place. So it's like an agent, a network agent that runs on each particular node, it runs on each particular node, and it ensures that necessary rules are put in place to allow worker nodes to allow containers running on them to reach each other. So we all said Docker had this restraint of containers, managing them and networking with each other and the like. They are not able to talk to each other. But when it comes to Kubernetes, you are able to talk to each application as you want. That's what we call pod networking. And kube proxy is what actually does that for us. So it creates all those IP tables and the necessary, or is the one that assigns network to each particular pod or component. Then we have container runtime. This container runtime is we've all heard of Docker. We heard in Kubernetes space, it is necessary to actually have a container runtime so that these applications that you have can run. And we have container runtime such as Cryo, Docker, Containerd for this purpose. So I hope everyone actually tries to understand what I'm giving out. Next we have Kubernetes features, and on Kubernetes features we have these features are things that Kubernetes does, or when you say something has like a characteristic, this is what we're talking about. So Kubernetes actually has automated rollout and rollback. So as I was giving an explanation before where I said companies do upgrades for their applications, for instance, or they release versions of their applications. When they release these versions of the application, maybe for instance they release 1.0, they're using 1.0 at the moment, and they want to do an upgrade to like 2.0. Now, by the time they do a rollout of this 2.0 and people start using the application, for instance, some people might not like the interface, or maybe there might be issues that are on 2.0, and the company now sees that okay, they want to revert back to 1.0 so that they can work back on 2.0. What Kubernetes does for us now is you can be able to do automated rollouts and automated rollback. By this time where companies are doing this particular rollback or That there tends to be like a downtime when you're not using Kubernetes for your processes or for your applications. So at that point, you might see that network or the endpoint for these applications that you're using might not be available. That's why sometimes you go to some website and you see that we're carrying out maintenance or something like that. This might be one of the issues that they might be having, not using Kubernetes. So Kubernetes now, what it does for us is that it ensures that there's no downtime and you can be able to roll out and roll back your applications or your versions that you have without causing any downtime. Next, we have horizontal scaling as a characteristic of Kubernetes. And what it does for us is that it scales your application up and down, like I explained before, based on your CPU usage and whatever resource limits that you're giving to it. So when you have, for instance, like I was explaining, when you have too many traffic on your application or your server, and you see that you have too many traffic, what companies do is that they will now start spinning up new servers by themselves to replicate or try to make sure that they replicate the same thing. What Kubernetes does for us now is you don't need to go and start spinning up servers to be creating new applications or new environments for your application for people to use to be able to load balance. What you can use Kubernetes now to do is just create replicas of those applications, and it's smart enough to use its resources like ingress and all or load balancers to speed this application for people to use, and you see that they won't have issues. Next, we have service discovery load balancing. So, when you're talking about service discovery, there's no need to modify your application to use like an unfamiliar service discovery mechanism. So, when you have like a load balancer, for instance, you create a Kubernetes cluster on AWS, you can create a load balancer and give it like a single name DNS that you can use to balance your application across the port. Uh, the next one is we have storage orchestration. We all know that storage is part of the things that you will also need when you are creating your applications or whatever you're doing that contains collecting data for people. You can use on Kubernetes, you can actually automatically mount storage system of your choice. So there are different storage systems, from your local storage actually to having a public cloud provider give you a particular volume. So on AWS, you have heard of EBS volume. On Azure, you can use their network share folder, NFS, Ceph, or Cinder to actually, what you just need to do is you just configure that particular on any cloud provider. There's a way you can actually, configure your application or your Kubernetes cluster to use any volume from any cloud service provider. Then the next one we have for the characteristics of Kubernetes is self-healing. This self-healing comes in such a way that when your service goes down, for instance, or your server goes down, maybe you are using the normal way of doing things. When it goes down, sometimes you might have to go back and restart it by yourself. But what Kubernetes does for us is that once a particular container actually goes down or fails to come up, it automatically tries to restart that application by itself. And once it sees that it is not going to restart, it tends to actually kill that container and spins up another one so that the clients can be able to use them. Next one we have is secret configuration management. When you're building applications, there are some key things like passwords and some kind of data sensitive things that you need to will I say you don't want the outside world to actually have access to them. That's why you see that most programmers or software developers or engineers, when they build their application, they don't put their sensitive things in the application or the GitHub repository. They create like a .env environment variable to hide those things from people. So what you can actually do on Kubernetes is you can create secrets and configuration management that you need to actually work on your application. Now on that cluster now, once you create these things, you can declare them separately from your application. And once you apply them on the cluster, it automatically picks it, maybe because you're having like a selector, or will I say, you're having like a selector, a label that picks up whatever from these secrets and configurations, or what we call config map. Now go down to like the resources, like I was explaining before. When you're dealing with Kubernetes, you hear of container, you hear of pods, you hear of service, you hear of deployment, you hear of replica sets. And as it is here, as I was trying to explain the other time, a container is where you can hold your application code, dependent libraries, and its dependencies all the way up to the kernel. So this kernel is whatever server or whatever operating system that you have. So the key concept here is isolation, which helps to have a better control. So you are packaging all your source code, everything you have as an application into one particular system. And once you create that, things like Docker, Buddha, they can be able to build your application and you have them as a container. Next, we have is pods, and pods are the smallest execution units in a Kubernetes cluster. Please don't mind my drawings or the figure you see here. It's just an explanation of what we were talking about. And in Kubernetes, containers do not run directly on cluster nodes. You cannot just carry a container and put and say, okay, you have to run on this node. Instead, one or more containers are encased inside a particular pod, and all applications in a pod, they share the same resources, local network, for easy communication between the applications. And pod utilizes an agent on each node called kubelets, like I explained, to communicate with the kube API resources and the rest of the cluster. So here we have a container. This is our pod. We have a container, and you can have at least one or two containers inside the pod. And this is like a volume, like I was talking about. You have shared volume that you get from maybe your local storage or any cloud service provider. All these things are encompassed inside the pod. Then you have your networking, which Kube proxy actually does for you. So this networking now is what you'll be able to using to access whatever application you have in this pod. Next, we have as a resource, we have replica sets, and the main responsibility of a replica controller actually is to create replicas of a given application or a given pod. So remember when I was talking about pods. So when you're talking about creating so many, maybe you want to do a scale up and scale down of your applications. Maybe for instance, you have a target group of like 1,000 people, and you see that ID, and you get to see that you have like 1,005, and let's say what you have as a resource on your platform can be able to take only 1,000 people. People start to have issues trying to connect to your service or your application. So what replica set does is when you are deploying is you create replicas of those pods which have your application inside them, and you can be able to use or scale up and scale down to how many replica sets that you have. So you have here, you have your pods, and you can clone them to whatever number that you feel can be able to reach those particular people that you're trying to reach out to. The next we have is deployment. So deployment is a higher order object which uses replica sets to manage replicas. So the best practice for using a Kubernetes environment is to deploy your applications as a deployment. So in a deployment sense is that it also gets the replica set. So as you can see from this point, we have this particular image here, and when you are deploying your application, you have to deploy them as a deployment. So deployment just takes everything you have as a replica set and pushes it to the production environment. Next, we have service. Service is a controller object, which prime responsibility is to work as a load balancer in distributing packets. When you have your network, people want to actually have access to your application. So what service does is, because when you create your application actually on Kubernetes cluster, there's what we call, on the service end, we have different types of service. We have cluster IP, we have node ports, we have external IP or external name, and we have load balancers. So these different services, you can use them. And when you talk of cluster IP, because when you're working on your application, you want to test if your application is working internally. That's when you use or you expose your application as a cluster IP, and you'll be able to access it from maybe using a call a call command to just check the IP of that particular pod if it is working. When you want to expose it to the external end, you can use either the node port, that is the IP address of whatever server that you have, or you use a load balancer to be able to help people reach out to your network. Now, best practices for deploying and managing applications on Kubernetes clusters. We all heard of different things when we are in different organizations, that there are some things that you might not need access to. When you get to organizations, you hear, okay, you don't have access to this, you don't have access to that, and all. So as a Kubernetes administrator, your sole job is to restrict access or give limited unlimited access to whoever needs it. So it's just based on, okay, this person should be able to do this on this particular cluster, this person should be able to do this on this particular environment. And that one of the best practices of doing that is to, I don't have it here, but it's to create a role-based access control. That's what we call RBAC. And one of the other things to also use or practices to use namespaces, to organize your objects, create logical partitions in your clusters for security purposes. So for instance, somebody does not just come into your cluster and just do anything he wants to do. So for dev environments now, maybe you have developers that are working on front end and back end. You want to give them access to your Kubernetes cluster. So you can be able to create namespaces for these developers. So you can create a namespace called front end engineers, and you can create another namespace called back end engineers. So for that purpose now, front-end engineers will not be able to have access to back-end engineers clusters or whatever resource that they have there if you use the role-based access control for them. The other thing for best practices for deploying, and managing applications of Kubernetes is readiness and liveness probe. For they're like maybe your health checks. We've all heard of maybe health check from maybe the head of health check from AWS when your server is not responding and maybe it's failing one or two things. But on the Kubernetes part of it, they are very, very, very important concepts to utilizing Kubernetes. And readiness probes ensures that requests to a pod or whatever service that you have are directed to the pod when the pod is ready to serve request. So if the pod is not ready, then the request will just be directed somewhere else. Then liveness probe, it's test the application if the application is running or working, or to check if it is healthy. So for example, a particular part of your web application could be tested to ensure that it is responding. So if you have maybe yourbizedge.com/ maybe pricing, for instance, as an endpoint, you want to make sure that that particular endpoint is working, or it is responding to request. You use your liveness probe to test that from the back end. Then another thing we can use on as a practice for deploying and managing Kubernetes clusters are using resource request and limits. When you have, for instance, your laptop has a memory size of 4 gig RAM, or let's say for instance 8 gig RAM, 256 of, let's say for instance 500 gigs of hard ROM, and you want to spin up a virtual server, or a virtual you want to spin up a virtual server, and you get things like VirtualBox to install those things. You have to allocate resources to that particular virtual server or VirtualBox to be able to run maybe another operating system from your system. So what you can do in Kubernetes now is you can allocate resources. You don't want a particular pod to use more than 100 megabytes of space, or you don't want a particular resource to use 1 gig of space. So this is like one of the best practices that you can use, to get your request limit and all. The next one is so these are like most of the things that you might get to understand through though you get to read more on Kubernetes. I'm just trying to give us an insight to understand basically what are the things that you will need when you're going into Kubernetes fully. The documentation for Kubernetes is actually like a very broad book that if you take your time and you go through Kubernetes videos, materials, it gets easy, and there are steps for us to be able to learn more. And this particular space of doing Kubernetes is not just you pick it up today and you use it and you don't use it again for like next 3 days. There are some things that you tend to forget. Going into Kubernetes, you have to understand your pod networking. You have to understand networking generally. You have to understand how to create an image from Docker and the like. So you need those background before you can be able to dive into Kubernetes fully. The next thing I'm going to be going into is to show us like practical installation for environment, and you can install Kubernetes on different platforms actually. So locally you can have your Kubernetes, or maybe you're on on-prem system and your organization is using Kubernetes clusters. So they can make use of kubeadm, you make use of Minikube, make use of Kind. There are so many Kubernetes environments out there right now, and one of the ones that you can use to practice or have a good feel of what the technology actually does is Minikube and Kind environment. So Minikube is a local Kubernetes cluster, or that focus on making it easy for you to learn Kubernetes. It's a one node cluster, so it just has a control plane, but you can be able to test the environment, and um, all you need is Docker as a container runtime, or you can use container D. You need a virtual machine environment, and Kubernetes is like a single command away. You just Minikube start. These are like the links that you can go to. I will be performing the practical soon, and you see how you can spin up Kubernetes cluster using Minikube. The next one too is Kind. Kind is a tool for running Kubernetes clusters locally. It also uses Docker or Container D as a runtime, and it's used for testing Kubernetes clusters for development and all. So Kubernetes is actually built from the Golang, the whole head of Golang programming language. So these packages are actually built from Golang, and when they interact, they are using the Golang programming system. As a DevOps or a Kubernetes administrator, you might not really need to understand what is going on at the back end or of what they do, but just have an idea of using Golang packages and how you can actually use them as your day-to-day. That will be all. So we'll just go down to I'll stop sharing this particular screen or end the presentation, and we'll go down to practical. So does anyone have any question before we go forward or move forward? So if there's no question, I'll just go to doing the practical for someone has his hand raised up.
How about we
okay, gather, you can gather the questions, and at the end of the session you can just attend to them, right?
Exactly.
All right. So for a Minikube installation, I'm just going to be using my AWS account, trying to launch an instance to run Kubernetes. And one of the most stable Linux environments is for Ubuntu that we're going to be using is version 20.04. So just going to be using that. Let me just use this as a name. Minikube, and let's go down to the documentation for Minikube. So most of the time you need this documentation, as your day-to-day. So for running a Minikube, cluster, these are the kind of things that you need. You need to understand how to run them and the kind of resources that you'll be needing to run them. So for your Minikube to actually work on any environment that you have, you need to have at least 2 CPUs of space, or 2 CPUs or more. Then you need about 2 gig of memory for your RAM, or as it can go higher. Then you need at least 20 gig of free gig space so that you can be able to run them. Then another thing is you need to also take note of virtualization on whatever system that you are trying to spin that on. So your system should have a virtualization enabled when you're trying to install those things on maybe your local workstation or your on-prem servers. But because we are taking our server from AWS, I believe we already have virtualization on what we're going to be needing is just we're downloading a container runtime, which is Docker. So because we are going to be installing on Ubuntu, we will have to pick, Linux here and follow the steps to install Minikube. Okay, so I can choose here 20.04. That is stable. And yeah, so now we get the instance type. So you see that on AWS, I have free tier for 1 vCPU, and this is not enough to actually spin up my Kubernetes cluster, because by the time I start it, it's going to give an error. So I need at least from here, they said 2 CPUs or more. So we're going to be looking for instance type that has two vCPU, so which is our T2 medium here. So I'm going to be picking that and selecting a key. So I have this key on my system, and I'll just choose a particular security group which I actually have before. Let me just pick this. Let me pick this one. Sorry, I have to remove one. So I can allocate 20 gig of space here. This is for storage. So that is that for the whole options I have to pick, and I can just launch my instance. So it's just one instance I'm going to be launching. So I want to connect to my system. I have my key. So instance is up and running. And view instances. So we see here that the server is running and it's still initializing. So sometimes you have to wait till the status check is ticked, so that you might not have issues connecting to the server. So here we have our server information, public IP, DNS, and all. But I want to connect now to the server. Let me just try. So I have my key already on my system, and I'm going to connect to it here. So like just do space this connection. Yes, so I'm on my server now, and I want to start the installation for my Kubernetes cluster. So permit me to just do this. So we still see my screen? I hope it's still visible. I just want to make sure that I can be able to switch from both things, so that you can see what I'm doing. So I have down already my Kubernetes documentation. So before you be able to install a Kubernetes cluster, you need an interaction that that is called an API that will be able to talk to the master node and the worker node, and that particular tool is what we call kubectl. So on Kubernetes documentation, you can just check how to install things. Yeah, so you can see here install Kubernetes or kubectl on Linux. So this command actually is what would enable me to be able to talk to whatever cluster or whatever Kubernetes environment that I have. But I'm just showing us when taking up things. So on Minikube now, we want to install Minikube. I have where I go to. You can, if you don't want to use the documentation, actually you can pick up can pick up something. Yeah, let's go here. So I have this. Yeah. So there's some good documentations out there that you can use to follow up on installing just a Kubernetes or Minikube installation for yourself. So most of these things that they have here are what are on the documentation. As you can see, you have them here and you have them here. So what this command is trying to tell us now that we need to download from their registry, and you're changing the mode so that you can give Minikube access to be able to perform any operation, and you are moving that particular Minikube file to your bin, and it's creating a path for you. But before we install anything first, we need a container runtime, and before for connecting or let's say installing a container runtime, we want to install Docker as a container runtime. So I have one good documentation here from DigitalOcean. It's pretty easy. You just go to the documentation, or you could use Docker documentation as the case may be, docker.io, to install your to install Docker on your particular system. But I want to make things fast, so I'm just going to do this, copy most of the things that we have here and install Docker. So on my machine, I'm just going to do that, just update some repositories, and let me clear my screen. And go here. Now we're installing some prerequisites for Docker to install. So press yes. So if we're doing this on maybe our local machine too, you might just need to have Docker desktop, the application on your system. So you need just to start the application, and you'll be able to run most of these things. But because we are working on a server, we have to install Docker on the system. So now we have to install Docker. This is it. So just going to put -y there so it doesn't ask for a prompt. So Docker is installing, and here you can just check the status of Docker to show that it has installed. Still running. So it's done. Just going to clear my screen here. And you see here that Docker is running on this server. So next is, because we want to give Docker privileges of performing any command. If I do Docker PS now on this particular server, I might not be able to access it because it tells me permission denied, that it needs to know where this particular command is coming from, and Docker does not have the sudo right. But if I perform this operation here, putting sudo at the beginning, it's already says that this is coming from the root user. So yes, but I can do that and just give Docker, add it to a user group, or modify the user group for Docker, and you are good to go. So if I do Docker PS, so I have to exit from my server and come back in, then that should be fine. So I'm back, and I do Docker PS. See now that it has been added to the sudo group, and you don't have that issue of kernel error again. So the next is installation of Minikube. All I'm just going to do here is just copy everything here. And paste it here. So what it does is it collects the repo from it online and stores it there. So if I do Minikube now, see that it knows or it sees that Minikube has been installed on the system, so you can perform any operation using Minikube. And we have can check the version of Minikube, and you see here that it's the latest version, which is 1.29 for Minikube. So next thing we have to do is, because we have not installed that the command for our kubelet, so we'll go to Kubernetes documentation. You can copy this out from here. It's saying that download the latest release with the command. But if you have a particular version that you want to go back to, that you want to use for your Kubernetes or your kubectl, you can just use this command and pass in the version that you need. But the latest Kubernetes cluster right now is version 1.26. So we're just going to grab that and it's going to install. So that is installed. This is optional, but let's just check. Let's just do some check some file. Download that too. So we're going to check if it is there using this command here. So what we're going to see is it's just going to tell us, okay, that kubectl is already installed. So next one is we want to move and give kubectl the permission to perform any operation. So we're going to move it to the local user local bin, the same thing we did for Minikube too, and it has the permission. So if you have kubectl now, see the same thing tells you, okay, what you can do with kubectl, the basic commands that you can do, the prereq commands and all. Sorry. Sorry. Can we see me, please?
Yeah. Yes, we can still hear you. Yes, we can still hear you.
Is my screen see? Is my screen on?
Yeah.
Is sharing still on?
Yeah, the sharing is still on. Everything's okay.
All right. So I'm coming. Just had power interruption, and okay. So kubectl is now effective. So if I clear my screen now, I can be able to start up my Minikube. So I've installed the container runtime and I've installed Minikube. So next thing now is I want to start Minikube, which you have here. I want to start it so I can start using it. So what I can do is Minikube start, and once you do this, it goes and finds the driver or the container runtime, which is Docker, and it will start pulling the resources to that are needed to install Minikube. So just going to wait some time. It's going to wait some time. So as you can see, it's creating a Docker container. Assuming we use T2 micro or T2 small, we're going to be having errors at this point because it's not going to have that required resource to be able to, pull up the installation complete. So see here that is pulling Kubernetes version, the latest one, and it's generating some, certificate and keys, booting up the control plane, which is the Minikube, setting it up. So it's verifying and it's done. So now if you do Minikube, let's do this. If you do Minikube status, you want to check if Minikube is running. You see here now that Minikube, the type, control plane, the host is running, kubelet is running, API server, and kubeconfig is running. So the same thing too goes for whatever cluster tool you might be performing operations with, like kind, kubeadm, and whatever. So we're just going to perform some good operations with Minikube. Especially want to get the nodes that are available. So what we can do is we want to talk to the Minikube cluster, and we have to use our kubectl, get nodes. And once you do this, it tells us the particular nodes that are in this cluster. So we have just Minikube, which is our master control plane, and it's a single node cluster that you can use to practice and do whatever you want to do. If you check if there are any applications on your Minikube cluster, go kubectl get pods. There's nothing there because we have not installed anything on our system yet. So there are some default things that are on any Kubernetes cluster. So if you do kubectl get all, there are some things that you see. No, not get all. I want to get all the pods that are in this cluster. So I can do this, and I see everything running. Now, as I was explaining the other time, where I had storage provider, kube scheduler, kube proxy, kube controller manager, kube API server, etcd, core DNS. We all see all these things from what I was explaining. So in any cluster that you have as a Kubernetes cluster, all these things must be present and they must be running. You see the status here. You see that each one of them is ready. You see the age, that is, we created this cluster like 2 minutes ago, and you see them that they are running. So this is like all the things that we talked about, and they all work intertwined with each other. We want to do like a practice, for instance. I have here a an example that we want to create. So let's say software developer has actually built his image and pushed to Docker Hub. He has a Docker application of the name School of DevOps /vote, then the hyphen, that is the tag, maybe version 1 for instance. And they say you as a Kubernetes person, you need to deploy this application on the Kubernetes cluster. So what I'm going to be doing now is just to create a particular pod that is named Start App, and to run as an image using School of DevOps /vote. So I'm just going to copy that, and I want to create an application or a pod. So if I do kubectl, so it always kubectl, or if you see that this is actually too long for you, you can create an alias that is, you can just pass in what you want to be called kubectl. So you don't have to continue typing kubectl all the time. So in my case here, I can just do k equals to kubectl, and I pass that. So anytime I want to run kubectl command, I just need to type k and create whatever I want to create. So for us to create a pod or an application on your Kubernetes, you need to do like kubectl. Let me just do it now. Kubectl run, and like I said, we had to create a application named stack app. So I'm going to do kubectl run stack app, right? And it has an image of School of DevOps, vote something / vote. So all I'm going to do now is pass in the image that it is going to use, and can do equals to, or just create a space and insert School of DevOps as the image name. Let me just put it as equals to. So once I do this, I can be able to create a pod. But I want to show you what exactly we are creating and how Kubernetes is actually smart enough to create a file for you. So if I do a dry run, I want to show them now in a YAML format of how the Kubernetes actually runs your application for you. I want to do a dry run client. Then I'll pass it as OYAML, as a YAML file, and save it as, let's say, a pod file. So pod.yaml. So I do this, it's going to save this particular application manifest inside this pod.yaml. So I'm going to be having this. So if I do ls, so I will see here that I have pod.yaml. Yeah, right here. So I want to check now the content of this particular pod.yaml. I can just add my pod.yaml and see that Kubernetes is smart enough now to create a manifest file for you for this application you want to build. And you have, this is the format that it follows. So it's APMS. So you have the A stands for API version, kind, metadata, and spec. These are like the foundations of writing a Kubernetes manifest or YAML file for any application. Either you're creating a pod, a deployment, a service, a replica set, an ingress, network policy, whatever. So I want to show us something from Kubernetes documentation. So if I go here and I don't know exactly before how to create a pod, I can just type here on the Kubernetes documentation and search for pod, and you have there. You can just go here. It explains to you what exactly a pod is, how you can use cases of using pods, and workload resources, and how you can do so many things with pod templates. So now you see here that you have the same thing that I actually just performed as an operation as a file. You can see it here on my terminal. So all these things, all Kubernetes clusters are smart enough to create this particular file for you. So if you copy this file or you send this file to somebody else, somebody can actually recreate this particular application with this format that you have.
Sorry, Anthony. Sorry. I'm trying to look at the screen. It seems like some of it might be a little bit cut off. Is there any way you can move it to the side?
Okay, I'm coming. Just hold on for me.
No problem.
Is it fine now?
Yeah, it's fine now. That's all. Wait.
Oh,
Yeah, it's fine now.
okay. So I have this here, and you see that it's smart enough to get, all these required things I have here from, my support spec, file. So now I want to create an application now from this particular file which I have created, with this pod.yaml. So all I can do now is, do kubectl, create, then, I have to pass in the file name for creating that pod. So I can do this and do kubectl create -f pod.yaml. And you see that it is smart enough, and it tells you that this particular application that we have, that we passed in as a name here, is already created. So you want to check now to see where the application is, or whether the application has been, deployed. So you do kubectl get pod, and you see now that that application is running. But it's only running from inside your Kubernetes cluster, right? People outside now cannot get to into place. Like I said, you need to expose this application to the app. Expose it to use the IP address from your server, from this server now. You need to be able to access from this server IP. So this server has a private IP of 3.90. So you want to access the application from this server. What do? You need to create a service for your application. So let's do this. We have to check the services that are available. So kubectl gets services from Kubernetes. So as you can see here, we have only one service, which is for the Minikube cluster, and we have here an application that we need to expose, which is Stack App. So we want to create a service that will be able to expose Stack App, and all we can do is the same thing we did for our Kubernetes pod when we were creating a pod. But this time around, if you don't actually understand some concepts in Kubernetes, you can go now, for instance, you want to create a service and go back to the documentation and look for services. And Kubernetes is smart enough. Tells you, okay, this is where you're supposed to go to. You want to define a service, you can copy all this out and go and create a service. But you can also do it, there's what we call declarative and imperative style. And what I want to do now is I want to just, expose this particular pod which I have here. So I can do kubectl. I'm not sure exactly how to, or what exactly I need to do on my Kubernetes cluster about a particular resource. I can actually get explanation from the kubectl expose. For instance, I want to expose an application, expose pod, and I do -help. Oh, sorry, it's -h. Kubernetes gives you an example, or it's like gives you an example. It has a documentation internally that tells you that, okay, you have examples how you can expose. This is RC, which we call a replica controller, or you want to create a service for a replication controller. You want to expose a pod. You want to expose this and that. So it gives you an idea of how you can actually, write your own file for exposing anything. But I want to do this now. I'm clearing. So I want to, expose my Kubernetes pod. And see, I want to show something. Show something. CTL get pods. So I have my startup here. I want to check exactly what is inside or what the pod is or what is inside the pod. Like you want to check the characteristics of this pod that is running. You can do kubectl type pod, then you pass in the application name, and we have this. So if I do this, I see everything that is inside this pod that we have created. So if you check it now, you have the name, which is Stack App. We gave it. It's on the default namespace. It's on default service account. And you see here that it's running on Minikube. Then you have labels from the application. So the label it is using is run equals to Stack App. So this is the IP of this particular pod that is running. So if you create another pod now, it's going to give it another IP. It's not going to use this one. And when this pod eventually it maybe fails or dies or you stop it, once you create another pod with this same image, it does not come back to this IP. It creates another IP for you. And you see here that it's using a container ID from Docker Hub, and the image is School of DevOps /vote1. Image ID is this, and now when we're talking about what this controller manager does and all, you see the events of things. See now that the scheduler actually has scheduled when you actually created it. It tells you, okay, this is the events that went on when building this application. The scheduler has scheduled the application and it was successfully assigned to Minikube. So let's say, for instance, we have node 1 or worker node 1. It's smart enough to schedule it to either any node, and you see it here from the event. Then the kubelet is the one that I said interacts with the Kube API server, and it tells you, okay, this is pulling this image which we have here. It's pulling this image from the Docker Hub. It's actually telling you, okay, it was successfully pulled, and it took 3.29 seconds. It created the application of the container stacker, and it started the container. So this is giving you an history of what you have done or what is inside the application. So I want to be able to expose this application now. The way you expose it with service is that service has to pick a label from or a selector from your application. So if I do kubectl expose pod, because I want to expose that pod, I have to create a service. So if I'm doing this now, I have to pass in a name. Sorry, expose pod. Then the name of the pod is Stack App, right? And I want to give the name of the service that we want to create. So let's say we do app service SVC. That's the name of my service name. Then I want to put pass a particular port. So I can do port 80, and I want to be able to access that particular port from outside the network with the external IP, which we have as our server. So I'm just going to do type post to node port, and I press OK. So now I do kubectl, we just use K, get service. So there are different short forms that you could use for in Kubernetes clusters. You have service, which is SVC, you have pods with PO and the likes. So before we had only Kubernetes as a service, but now we see that we have created a service which has app-svc, and it's running on node port, and it has a cluster IP of this, and the port number is 31369. So if I do kubectl describe service app /svc, I see that the name of the service is app-svc, namespace is default namespace, and it has picked the label from your pod which you had, which was run equals to stack app, because you identified expose pod stack app. That's the name here, and it picked it up, and you have your IP, you have endpoints and all. But because this is a single node cluster, right? Minikube has its own IP address. If we do Minikube, so what I'm going to do here is I'm going to do kubectl cluster info, and you see that Minikube here is running on 192.168.49.2 :84483. But our server, which we have here, is this. So there are two different things, and we will not be able to access our application from the internet right now, because we have not, though we have put, we have exposed it on the node port, but we'll not be able to do that because we're having a node, a cluster inside another node. I don't know if you get me, but I want to be able to expose this now. I will have to, do a port forwarding to that particular node port which I have. So if I do get service, so I have my port number here, which is 31369 for this node port. So I want to create a port forward to get my application. So I can do port forward. If I don't understand how to port forward, I can just do this. It tells me, give me a list of what I can do to be able to port forward my application. So you can listen on ports or this, that. You see examples. So right now I want to expose my application to run on any IP that I have. So I'll do this and just edit. So I'm exposing a service with name /svc. So the port number that I have used here is 31369. I can just paste it here. And the other port number, because it's going to be accessing through HTTP or HTTPS. I'm going to be using port 8. So I can do this and I port forward. So now it's telling me that port forwarding from 0.0.0.0, then port number 31369. So if I go down to my app now and I do this, I do this and add the port number, I should be able to see my application running. So that is, you see now that it is handling connection from 31369, and you have this sample application, nothing much, nothing more. It's just basic. So this is what Kubernetes can do for us as an application or a container management tool. If you want to, for instance, if you kill this application, or for instance, if I just cancel, okay, this is going to stop. I think it's going to stop because I've stopped the connection from that point of entry. So I hope we all understand some basic concepts This is just to expose us to what Kubernetes can actually do for us. It's not a full class or anything, but just to give us an idea of how we can actually run Kubernetes clusters on different. So the same thing too happens when you want to run on your kind environment. There's what we call kubeadm. There's kubeadm, uh, kubeadm, kubeadm. So most of it, you check here, installing kubeadm. You see the same thing. So you have how you can install them on your environment. So that's it for me. Any more thing you might need to actually get involved with Kubernetes, you can get them from documentation, or there's so many let's say people now that are trying to create content for it, for people to understand how you can use them. So that's it for me. Chidi.
All right. Thank you for this great webinar now. Thank you for coming on. I'm more of a finance guy. I'm more of an Excel and Power BI guy, data analyst. So learning all about Kubernetes right now is a whole new field and something I really want to start getting into. So thank you so much for introducing me to it. I was following as much as possible, and it's very, very interesting. I just need to get my hand into this space and really learn more about it. So I said at the end of this webinar there'll be questions, and I hope Mr. Anthony will be able to attend to everyone. So anyone have any questions? I'll start. If you can put it in the chat, and he can discuss it then from any of our attendees or participants. Or if anyone has their hand up, I can unmute you and you can have a conversation with Mr. Anthony. Any question at all on the 1 hour and a half webinar?
Or the other time, our Aviatrix solutions.
Oh.
Okay, thank you. I think to be honest with you, the session is actually very interesting. I've been diving myself into DevOps, but it has not been this direct and easy to deploy. Because to be honest with you, if you want to do an interview, possibly this is exactly what they'll just ask you to do. And if you can do exactly what you just did, you get the job and you're on 6 figure. So my question is this: what is the difference between a cluster and a pod? But when you were getting to the end of the class, I was understanding the pod because you deployed it. So when you are on AWS, how does it relate to that pod you have done? Then number two, the question I want to ask is, by the time you finish deploying that app that was live on that URL, the IP 3.90.199.211 with the port number of 31369, how did that IP address came about? I know the port number, you have assigned it in the port forwarding. How did that IP address 3.90 came about? Because without the IP, with the port number, you can't be able to see that Stack app come up directly. Thank you.
Okay. First thing is what you hear from you hear different terminologies, different things about Kubernetes. So I'm just using a platform here, which is AWS. I created a virtual machine, which is like Ubuntu server, right? That Ubuntu server now is like a node. Do you understand me? It's a node. And like I explained from the beginning, you create nodes, and your nodes can be a master node or a worker node. Do you understand me? Once you create those nodes now, it now depends on what cluster are you working on? So let me just pull this up. I don't know. I'm still sharing. Okay. I want to explain just something briefly for you. So, can you see my screen? Is it still up?
Yes.
Okay.
Yes, it's
Please let's just wait. Let this load. So, so now you have a Kubernetes cluster, right? This is a Kubernetes cluster. I'm just going to do a basic thing for you. So this cluster now you have, there's a node that is there. So in that Kubernetes cluster, you have a node, you have a pod. Your pod is inside your node. So your nodes can be worker nodes that you spin up, and you can have as many nodes as possible. You can have 3 or 4 worker nodes, as the case may be. Then inside those nodes now, you have this same thing that I have here, which I have as a node. I can have them inside here too, the same thing. So a node can take up as many pods as possible, but it depends on the size of that particular node. Do you understand? So if I'm spinning up a Kubernetes and a server now from AWS that has maybe just 10 gig of space, when it gets to its limit, you might not be able to spin up any pod on this particular node. Your kube scheduler now, or your kube scheduler will be smart enough to tell you that it cannot, you cannot schedule any pod on this particular node. Then it will push it to the nearest node that has capacity to install or deploy this particular pod. Now, when you have a pod, like I was saying initially, this is your pod, and inside this pod now, you have your container. Your container is an image that is running. So you are pulling your image from maybe a registry, which we have Docker, we have Docker Hub, we have different registries. There are private registries where people put their applications onto, and your image is actually inside your container. So your container is having all those dependencies and all. So if you are deploying your container, you are deploying it into a pod. So now there can be replicas of this particular pod that will run on any node. Do you understand me? And once it runs on any node, that means you are deploying that particular pod as a deployment or a replica set. So you can scale up or scale down how many pods that you want on a particular node, or you want that should be up and running. Then the next thing that we're talking about, the IP address. So now I have this particular server. This server is serving on a public IP of 3.90.199.211. That is the IP of this server. So we want people now, for instance, what goes on at the back end for people that are not, into the software engineering part and all the deployment thing. When any application is, maybe for instance, let's not even use Kubernetes. People spin up servers and they deploy the servers on they deploy the application on servers like this, right? Once they deploy the application on these servers, it is this IP address of this server that the external people are trying to point that they are accessing, but they change this IP address and resolve it to a DNS, or a DNS. So that DNS has maybe you see www.google.com, but at the back end of that google.com, Google has an IP address. Do you understand? So it is this IP address now that we are using, because we have already identified on our node here. If you check, when I did kubectl get services, I already identified that we should use a node port, and this node port is the node port, or is the external IP of this particular server, which is the public IP. But if we're using a cluster IP for this service, we will be only able to access that particular application internally inside this server. So people outside will not be able to use it. But you can also use a load balancer as a type of service. Your load balancer now carries your you see load balancer name of any name that it has. That when you create a load balancer, there's a particular format that a load balancer has. So once you deploy as a load balancer, anybody to outside can be able to resolve to that application. See now, if I want to port forward again, I want to port forward, but I don't want to use this particular this ID that is here. Let's say, for instance, I'm using 6,000, right? It work. I change it here and I change 6,000. So it didn't work. The reason why is it didn't work. The reason why is we already identified inside this service that it should use this particular port number. So if I go back and change the configuration now to, let's say I want to, let's say kubectl get service app svc. I want to pass it to OYAML, and I save it as service.yaml. So I have already as a. So let's say, for instance, now I want to edit this particular node port. I can just edit it here. 6,000. Save it. But first of all, if I want to, I have to delete this particular one before I can be able to spin up another one. So I can just do a kubectl replace. Some of these things, it's until you get to work with them before you'll be able to learn most of these concepts that I'm using. I'm just trying to explain for quick purpose. So I do this. Sorry. Okay, yeah, it's within the range of 3 something. So sorry. I'm just going to port node is from 3,000 to 31,000 and something. So let's say I use 3,500. I'm going to do this. So I do this. So you see down that if I do get service, my app here will work on 30,500. So if I try to access on 30,500, I'll be able to get my application from this point. So the application will work. So it's all just part of understanding your networking, your port forwarding, and like I said, before you dive into Kubernetes, you need to understand networking, you need to those basic concepts, and you need to also understand Docker and all those other concepts that come before Kubernetes. I hope I've been able to answer your question and solution.
Perfectly. Thank you.
All right. So is there anyone else?
All right, so I have a question. Now, I don't have too much experience with Kubernetes, so take that as you will. Like, where, in my eyes, I'm viewing now, where is the code? Where is the JavaScript? What service are we actually running? So I can see that it's a sort of I'm definitely explaining it wrong, but this is my knowledge, like a data structure. You have I love that diagram before with the Kubernetes cluster. You have your pod, you have your containers, which is within a pod, which is within a node, and within a Kubernetes cluster. I love that diagram. But for
This
me,
one,
yeah, that diagram is great. I loved it because it
okay.
just explained that it's all part of a bigger system. So for me, I'm just thinking like, where's I'm used to looking at Python, Excel. I built some algorithms here and there. So where
Okay.
is the code actually located? What like when you showed us your application, like what is it? What could it or what is it actually doing?
Okay. So
That's what
so
I'm.
so for instance, you have if you're a data analyst, or yeah, sometimes you write scripts, right, for
Yes, yes.
applications. Now, so for example, that script, let's just take that script as an application. Now, when you build your application and you see that it's working for you locally, right? You want
Yeah.
to give it to the software engineers, or you want to deploy that application so that people can be able to use. Now, one of the good practices for doing this DevOps and be able to work with smaller, because what Docker, like for instance, what Docker does for you is takes your application, builds it, and gives us like a smaller image of your application. So maybe we are building your application on your system and it's going to almost like 700 megabytes to 1 gig. When you Dockerize your application, there's a way you Dockerize your application that it's now compounds all the dependencies that you have inside when you are building locally to a particular image. Now, places like Docker Hub, what it does for you is it's a registry. So I can sign in here, for instance, and if I have my this is my own Docker Hub repository. I have where I can push my application that I have built to Docker Hub. So for instance, I have here some applications that I have built like in the past. I can push them to Docker Hub. And Docker is smart enough that when you want to, call these applications, now you built it, and this is the name of the application, right? This is the whole name of the application. So if this is a public uh, image, right? If this is a public image, you can see here now that this is the application that was built. It's showing latest. It's showing latest. If you click the application component, you see here that the application is about 201 megabytes. This is the application. Everything that you did as a programmer is inside this image. So what Docker now does, or Kubernetes does, is it go back to picking this particular image name. Now, once you pick this image name and this image is public, that is, anybody can go on Docker Hub and search for this image and it comes out. But if it is private, which that is, you guys are working as an organization and you build your internal application, you have to store those things privately so that people will not be able to access them. So you create a private, repository for that application. So when you want to, work on Kubernetes on your environment, you have to sign into Docker with your Docker credentials so that you'll be able to access those images that you have on your Docker private repository. So it's just picking this particular name, which is Tony/PHP dash to do. Once you pick this, it is that image that you use. Let me cancel this and show you the get code. Let's just describe the code startup. So you see here that when I was explaining the code, you see here now that once I use the image of Tony oc/php to do as an application, it shows here that that is the image that it is using to run the application. So whatever thing that you have built inside that app is going to be is what Docker or Kubernetes is going to be running for you at your front end. Is that explanatory?
You explained it very, very well. No, that was
All right.
fine.
All right.
Okay, that was a great explanation. It's clearing up the fog I had before. I think I'm starting to get it now.
Okay, so that is it.
Okay.
All
That's
right.
great. And okay, so if there's any more questions, I'd like to go ahead and ask you my final two questions. So
Okay.
just give me just 2 minutes. It's two very simple questions, and it probably won't take too long. It's more right. So how did you get started in DevOps? How did you get started in this space? And if you can just give a brief summary of your career and how it's going. How did you actually get started? What sparked you to get into this Kubernetes?
Okay. So first of all, I'm this kind of person that actually likes to move on with new technologies that, technology has to, wow me. And when I looked at the DevOps space, not even the DevOps space, the cloud computing aspect, I think it started from 2020 during the COVID period. And I partook on programs like, Google Scholarship for, Google Cloud Associate. Um, that was one of the things that made me to, move into, DevOps. So I started learning how how you could use cloud platforms to work with different things. And I started with Google GCP. But at some later point, I later had to pick up interest in doing or working with AWS. And I started seeing that most of the concepts from both cloud providers are just the same. It's just that you just hear of different names, and those different names are just doing the same thing. I just had to learn, basic things from, cloud computing, what you're supposed to be doing on the cloud and the likes. But the main goal that I actually now had to do was in 2021. I said fully that DevOps was now coming into play, like um, more. I was hearing of it. I was, trying to like get interested. What does this technology actually do? That was when I saw that it was like, a bridge between. There was a bridge between, developers not being able to, deploy the applications and, be able to, do some kind of operations as fast as possible, do releases and continuous integration. Like they're working on the code, they are trying to like implement, some, changes to the DevOps does for you is, there's an infinity on that side, and I took interest in it. I already had knowledge of using, there's some basic roadmap for being a DevOps engineer. You need to actually know the basics, which is starting from using Git commands, learn how to, use GitHub, learn Linux. Linux is like the foundation of any, DevOps engineer, because most of the operations that you will be working with, like you saw as I was working with terminal, where things that you'll be interacting with daily. So you need to know and be familiar with most of these things. Then after doing that, you try to start picking up tools. In the DevOps space, there are different tools. You have Docker, you have Kubernetes, you have GitHub Actions for your CI/CD. You have CI/CD, continuous integration, continuous deployment, and it's all part of all the processes. How you will be able to spin up infrastructure without going and doing them manually. So one of the key things I've looked at doing is trying to learn most of these tools one after the other. Then when you learn most of these tools one after the other, you try to see how you can integrate them to doing one or two things. Like you start up with small projects, how you can use Docker and Kubernetes together, how you can use GitHub to write or do Markdown to write the documentations, because documentations actually as a DevOps engineer is like very essential, because you have so many things that you are doing, and at some point you might forget some basic steps, and it's documentations that you have written before that helps you to get to understand what you actually not remembering. So all those things are part of the things that has actually helped me. I have like a group of engineers, to self-minded people that will try as much as possible to learn from each other, you know, get practices from most of these platforms. And also in the DevOps space, I had the opportunity of working on different DevOps projects, right from Dari.io, where I'm actually working there right now. So it's part of the process. So as part of these things, when you try as much as possible to get to know most of these tools, try to implement most of these projects that you have, just minimal things. And at the end of the day, like Hami's solution was saying, when you understand the concepts, when you actually try to learn them, you'll be able to speak the technology, to be able to explain to people. It becomes inborn. You'll be able to pass on knowledge to people about these things, and that's what makes you like a good DevOps engineer at the end of the day. So you really don't need to know all, but know the basics or the important ones.
Okay, okay.
Yeah.
And with DevOps as well. Sorry, you can continue. I don't want to cut you off.
No, you can go on. I'm done.
Okay, with DevOps as well, I had the impersonation that DevOps was basically like auditing for code. So you check the quality of code, you make sure everything is okay, you make sure nothing's sketchy, everything runs the way it's supposed to run. Would I be right in saying that? Because
No.
even then, I'm just like, I look at what you do, and it's still
So
heavy work. It's still a lot of
when software developers write their applications or their codes, right?
yeah.
You see the same DevOps engineer, you see the same software engineers that write. No, it's quality, what they call them, QA people that do software testers. They write software codes to actually test the applications. So when you have all these people on your team that are doing this, they are doing manual processes. So by the time
Yeah.
a software tester writes his or her code or application code to test your application, you would actually integrate most of those things into your CI/CD. So your Jenkins, for instance, can be able to do from your application or developer trying to integrate one or two things. Once you just press a push of a button that it pushes to the main branch, CI/CD process is already put into place that takes the application which it has to maybe a software delivery or software integration or deployment like Jenkins or GitHub Actions. It goes through like a pipeline. So that pipeline now, it has built your application, turn it to maybe an artifact, for instance, and when it turns it to an artifact, or it checks now all those code smells and all. So everything is like inside a Jenkins script. So what they're just going to do is carry
Right.
or take a particular script that your software tester has given you and put it inside the Jenkins script, and it all goes through a particular process. So nobody is going to do anything at that point in time. So if your application actually fails, your software or your Jenkins is going to tell you that this application failed, so it cannot go to the deployment site. So that's how it
Yeah,
all works.
that's where Sorry, that's where I thought DevOps lived. They lived doing those Jenkins, they lived doing in GitHub. But this Kubernetes stuff, it took me out of balance. I won't lie to you.
Yeah, so it's like a, will I say, it's now what people should be going into more often, because it's actually stressful doing Jenkins, doing everything at the end of the day. But you use them, as a DevOps engineer, you use them. But when you want to do fast deployment and all, you really don't need things like your Jenkins and all. You can just pass in your application through Docker Hub and all those things. But you know exactly that before your application can actually get to Docker Hub, it needs to pass through all those processes from Jenkins or whatever. Because before you can be able to push the application to Docker Hub or your registry, it has to be validated. So it actually has to pass through those processes too.
Okay.
Yeah.
Okay. I think I get you now. And one more question before we finish up. So as a person who might not have too much experience, maybe a young IT person, or maybe someone in another field, whether it be another job, like how will that person get started? How would you advise that person to get started going into DevOps, maybe going into Kubernetes? Does that person need a mentor? Is this something you can learn by yourself? Is it something a young person can open up that documentation and learn? Or are you saying, no, you're going to need to work in an industry to sort of really get started? What do you say to that?
Okay, so first thing about the DevOps space is before you can say you want to dive into the DevOps space, you need to be committed to learning. That is like the important thing, because you can't just, maybe for instance, you as a BI person or Power BI person, you might have some certain skills that you know about, some technologies about the tech space, but you need to calm down on learning the basic fundamental about things. Start learning things like I said, your Git. You understand how to use your Linux environment very, very well. That is like one of the things that we cannot remove, because as a DevOps engineer, yeah, you'll most likely be working with Linux servers, either Red Hat, Ubuntu, as the case may be. So that's like your everyday routine sometimes. And getting into the space, like I would say, it's not hard. Most people, when you hear of UI UX, somebody today can just say, UI UX, this is tech that is coming up. You start learning wireframe and all those things and all. But in the DevOps space, you need to calm down and learn a lot of tools. So you need mentors actually. And when you say you want to go all out in learning all the tools immediately, you might not master one. So it's better you actually take a particular stack first, learn it, understand how to use it, then you can dive into another one. Most people dive into the tech space or the DevOps space because they want to make money faster, but which is actually the goal at the end of the day. But you know, we actually need to learn these things, because when you go out and you say you're a DevOps engineer, or you want to be hired as a DevOps engineer, technical questions that they're going to be giving you is not what is this, what is that, what is this. It is when you're in a situation like this, when you're in a situation like that, and most times you won't see entry level roles for DevOps engineers, because they want people that are DevOps engineers to have the experiences. You can pick, like me myself, I won't lie to you. I started the whole DevOps thing by myself. I pick up courses. First thing first was I tried to understand the whole roadmap to learning DevOps. And there's some particular stack that you have to see, that you have to know. So you can pick up any one of them. Then um, you need a mentor actually to mentor you, people that you can run to, not even mentor per se. You need a group of engineers that you can be able to run to when you have issues, you're trying to tackle one or two things, that can assist you, so that when one person is busy, another person is not busy. Do you understand? So they try to direct you on what you're supposed to do and how you can actually make headways. So
Cool.
I hope I answered the question.
Yes, you did. Yes, you did. Very
All right.
well. You answered it very well. I liked the last bit where you said you needed mentors. You get me? Because everyone is always like, you know, you can stay at home and learn this yourself, but you just admit it. Yeah, no, you're gonna need someone.
In any space, actually, in any you need somebody that you can actually say, okay, I'm stuck in this place. The person can be able to direct you on what you're supposed to do, even in the Power BI or the data analysis world. So it goes everywhere. So I think that's how it should be.
No, it definitely is. Okay, so I guess that's all. We'll wrap it up for now. Thank you. And at the end, we're going to link Mr. Anthony's LinkedIn and any other resources he wants to share. We're going to link it into the chat, and we're going to upload a YouTube video sometime tomorrow. And yeah, so I think that's everything now. Thank you so much for coming here and teaching us about Kubernetes. It's been fun. So I'll leave it be.
All right, take care. Bye, everyone.
Take care, everyone. I'll see you soon. Thank you, Anthony.